So the question asks us, how many different positive 5-digit integers are there such that its digits from left to right are non-increasing? First of all, we have 10 digits, 0 to 9. And we are required to pick 5 digits out of these 10 digits with a loud repetition that forms the 5-digit integer. Let's say we have the numbers 0, 1, 1, 9, and 7. In order to make these 5 integers into the required positive 5-digit integer, the first number we pick to go in the first place has to be 9. Because if it was not 9, then 9 would have to appear somewhere on the right of the first integer, which is less than 9, which do not meet the requirements. The same logic applies for the second one. It would have to be 7, as if it was not 7, 7 would appear on the right of 0 or 1. Since 7 is greater than 0 and 1, that will not meet the requirements. Applying the same logic, we get the last 3 digits to be 1, 1, and 0 in that order. So this would be the one and only arrangement of these 5 digits. Therefore, we have proved that with every 5 digits that we choose, there are only one possible arrangement of them to form the required 5-digit integer. So we can simplify the question by turning it into, how many ways can we pick 5 digits from the digits 0 to 9 with a loud repetition? Now you may have heard of stars and bars, which can relate to this question. We can say that picking 5 digits would be 5 indistinguishable balls. And the 10 digits would be 10 distinguishable boxes. Now we just need to put these 5 balls into the boxes. What I mean by balls is when we put a ball into a box, it would mean that we pick that digit. And each box represents a different digit from 0 to 9. So if we have 10 boxes here, representing digits 0 to 9, if I put a ball in the box labeled 1, that would mean I chose 1. If I put a ball in the box labeled 3, that would mean I chose 3. If I put 2 balls in the box labeled 1, it would mean I chose 1 twice. Let's say I put another ball in the box labeled 9 and the box labeled 0. Then we would have the arrangement 0, 1, 1, 3, 9. And as said before, the only corresponding 5-digit integer would be 93110. Therefore, we have simplified the problem into putting 5 indistinguishable balls into 10 distinguishable boxes. Now, stars and bars tell us that for k indistinguishable balls and n distinguishable boxes, the number of ways to put these balls into the boxes is the expression choosing k out of n plus k minus 1. So plugging in the values k equals 5 and n equals 10, we will get the expression choose 5 out of 14, which is 14 factorial over 5 factorial times 14 minus 5 factorial. And simplifying and doing calculations, we get that this equals 2002. Now at this point, we have only considered the arrangement of 5 digits. However, we have not actually checked if these arrangements are actually 5-digit integers. Now there are one arrangement that we have put into these 2002 that is not actually a 5-digit integer, and that is the arrangement of 5 zeros. Since it's a 5-digit integer, the first digit cannot be 0. Therefore, this does not work. So we actually have 2002 minus 1 ways, which is 2001 ways. And that is our answer. Therefore, we have 2001 positive 5-digit integers that are non-increasing when you read its digits from left to right.